Okay, hello everyone. So this is a talk on getting ARted with ARFoundation. Hope you all appreciate that. Great pun there. Are you ready? Good start, good start. So my name's Sorta. I'm a technical evangelist at Unity Technologies. Just a quick show of hands, does anyone not know what Unity is? Okay, that's really good. So yeah, my job is to go around to conferences like this and tell people how to do the tech side of the engine. So if you have any technical questions, feel free to either email me. I got very lucky with that email address, or just message me on Twitter. So this is what we're going to cover today. So we're going to go over what exactly ARFoundation is, some of the use cases for it, understanding what AR space is. So it's a bit different if you've done other Unity projects before, or if you've used things like Vuforia where it's marker-based. We're also going to go over visualization, and we're going to do a quick demo as well. So before we kick off, we're going to do a quick jargon buster. So we've all heard terms like AR, VR, XR, MR, whatever. A lot of industry people like to use XR. Yeah, it doesn't matter which one you use. So here's just a reality-o-meter, just to sort of gauge whereabouts we are on this spectrum. So AR is overlaying images on your device, about as simple as you can get. It doesn't necessarily have to be full world tracking. So probably markers are a good example of this kind of basic implementation. Then you have MR. So this is when you actually interact with these objects, and it actually manipulates the real world. So let's say we had this podium here. I could have a little character come onto it, walk around. That's actually interacting with the environment. So that's what people describe as MR. Then you have VR. So this is full body display in your face, not necessarily using the pass-through, it's all virtual. And then all of this comes under the umbrella of XR. So ARFoundation. So ARFoundation is a way for you to develop cross-platform AR applications using Unity. So we use both the native SDKs, so AR Core and AR Kit. It also means that you don't have to worry about any feature parity between the two. So whenever a new feature comes out that's available on both platforms, we'll support it as soon as we can. So it makes it a lot easier, especially not just managing your product, but managing the code as well. We also have a repository up here. You can either use the full link or the bit.ly link. And this has loads of examples of marker-based, facial tracking, world tracking, any types of examples that you might want to try. We have all the source code open there. We are still in preview with AR, so it's in a pretty stable state right now. There's a lot of people developing commercial applications with ARFoundation, but because of how many more features are coming and because of how quickly it's moving, we don't want to fully announce that it's out until we're very sure that it's good to go. So the AR industry is predicted to be worth about $60 billion by 2023, according to this very small link down there. I'm sure you've all heard of Magic Leap, who've got multiple billions in series funding just from the headset alone. So the amount of applications for AR are really bringing in all these new startups, a lot of new companies, even just in the form of agencies. AR is becoming massive in so many different industries right now. So if you are looking to get into the space, then now's the perfect time. So a few examples. I'm sure we all know Pokemon Go. This is Abra on the toilet. Very classy. But these are the ways that we can use AR in a practical way. So let's say we have an item and we want to mail it out somewhere. We can actually just use the fact that AR scaling is one-to-one. So we know exactly how big it's going to be in the real world. We see this with like rulers, things like that. And then you can estimate how much that's going to cost you for shipping. So maybe you run your own business, you ship out your own products. This way you can cut your costs, make sure you're only spending as much as you need to. You can measure a banana if you really want to. This is an example of using markers. So this was a card game I made at a hackathon about 3 or 4 years ago now. And because there's no way to define which player is who, we had to split up based on the screen. And as you can see here, this was quite a few years ago now, but even then, marker-based tracking is pretty damn accurate, and it's come even further now. Because we are still using Unity, so it's real-time 3D rendering, we can still interact with all these models as well. So we can actually just have these buttons where you can tap, attack your enemies, load up special attacks, good stuff like that. So this is an example of using it cross-platform. So here we have Android in the background, and then Apple just in the corner, which I'm sure you guys appreciate. But here we're showing off how world tracking works. So all you can see here is these little orange dots. So these are called feature points. And a feature point is anything that we find interesting in the world. So usually this is a different in shade, lighting, anything that we can define that space as that's quite accurate. Something that's not going to change. So a good example of that would be maybe these posters here. There's a lot of information on there. There's a lot of stuff for us to base our markers on. Whereas if we use one of these tables, it's a reflective surface. It's all matte one color. So it's going to be very difficult to establish tracking. Once we have enough of these feature points on a single axis, then we can make a fair assumption that this is a plane, a solid object. So what we do is we put our plane down, and then we remap those vertices based on what new information we take in. So maybe we get a new point over here, but it's cross paths with the speaker. So what we can do is it would break that original vertice map and then place a new one over here. So we're still retaining what this all looks like in the real world. So especially if you're doing I don't know, maybe like a car racing game, you don't want to be able to bump into real world objects. Here's a cool example from one of our conferences a while ago. And what we have here is this little robot guy using some AR immersion techniques. So as you can see, as this guy walks by, we actually shade the robot a little bit. So this is using light estimation. And that's where we shade an object based on the lighting around it. So if we're in a dark room, the object should be darker. Lighter room should be lighter. Also, what we have going on here is some real-time reflections. So if you look closely, you can actually see that there are reflections in the robot's head and around his body. So what we actually do here is, because we already have the camera feed, we can just wrap that around the sphere and use that as our reflection probe. And this means that we can have things that look as if they belong in their environment. Maybe you could see someone's face reflected inside an object. So all these things that make us feel as if this object's more alive, more immersive. And these are all things that have a bigger impact on the user. AR is all about immersion. It's about making you feel like it's there. So when we use these techniques, it just adds to that overall experience. So here are a few examples of what manufacturers are doing. So here's an example with, this text is very small, Hyundai. And what they're doing here is just overlaying these tooltips on a car engine. Same goes for this one. This is a bit more of a mechanical overview. And these are ways for you to educate people. If I want to learn about a car, I'm not a very car-savvy person. I'm going to go online and try and find the most visual example, because I'm not going to go through a car manual and look it up. But if I can do that in AR and see that in an intuitive space and actually interact with it, that's going to have much more of an impact on my education. Also, just placing furniture around your home. If you go out and spend 2,000 euros on furniture, then you take it back, decide you hate it. All of these different applications are about making your life easier. So if you can save yourself a few €100, then why not? Also, architects love it. So if you're trying to see what a building is going to look like, maybe you're going to show it to like your senior project manager, whatever. Any way that you can help get your idea across, be that on paper, visually, the more you can do that, the more that it's going to get what's in your head out to them. And a good example of this is the fact that because it is all one-to-one, you can actually put this in just an AR headset or just on your phone as well, and actually walk around the space in AR on a one-to-one scale. So this is an example of what the future of AR might look like. So this is all a concept video, but the logic behind it is pretty sound. So all we're doing here is we're just taking the information that we already have. So we can establish tracking on this car pretty easily. But from there, we can also get information from the world around it, so the thumb. So we can actually use this as a joystick if we want to, use it as a mode of input. And because we have all the rotation, the positional, all this extra information about that single object, we can do things like waving it around to dismiss whatever we have up right now. We also have all the device features. So maybe we want to send a message to someone. We can just tap on the cards, send a voice message using the microphone on your camera, and then send that all while staying inside this app. So again, the possibilities of using AR, especially as an overlay, not just using actual objects, is massive. And this is the bit I want to show. So here we can actually see how exactly this is being tracked. So the segmentation is where we isolate the thumb as the controller, again, using the positional data as a means of input. So this section is about exploring space. So if anyone's developed using Unity before, you know that pretty much everything's in world space. So world space is this what it sounds like. We have 2 points. We have the origin point, and then we have the distant point, whatever. So here we have 0, 0 in the bottom corner, and then 10, 10 in the top right. Does anyone want to be brave and guess where the character in the middle is standing? I'll pick on someone. Okay, you look like you're interested. I'm picking on you. So where do you think the character is in the middle on this grid? 5, 5. So pretty easy to understand. This is just an XY grid. Same for this logo over here, 2, 8. Then we have local space. So this goes, if you've got a big ego, this is great because the world revolves around you. Good joke. And this is where we have everything revolving around a single point. So we have our character in the middle now with 0, 0, and everything is positioned based around it. So the bottom corner is -5, -5, and the top is 5, 5. So this logo, which originally was 2, 8, is now -4 and 4. So session space, this is what we call deep space. It works in a similar way. And we have everything based around this local point of our device. But as soon as we move that device away, we still keep that origin point. So let's say this is my mobile device. Once I start this session, we're still going to keep this position in memory. So even if we move the phone over here, we're not moving that point. We're still keeping this point in the same place. So if anyone's done virtual reality development, the controllers and the headset work in pretty much the same way. We keep an idea of where that original position was, and then we track everything relative to that position. So a bit on visualization. So this is what we covered before, where we have feature points. But the way that we can do this a little bit nicer is actually we review these samples. And with these samples, you can then customize it, change how, maybe you want the feature points to persist. Maybe you want to build up like a cloud map of what this room looks like. All these different ways, and then you can then save that down. Maybe you want to pull it down later as a visualization of your room, whatever you want to do. So all this information we give to you through the API. Again, not platform specific, so whichever platform you're using, you can still get that data. And then you can customize it to your heart's content. So I'm going to quickly show you how exactly we can have an AR project set up. So if I change this to duplicate. Okay, so if we go over here, this is our package manager. So if you don't know how to access this, it's just over in Window, then Package Manager. ARFoundation is a preview package, so we'll have to go down to Advanced, hit Show Preview Packages. And from there, we can just type in AR. So ARFoundation, because it's essentially a wrapper, we still need to bring in those native SDKs. So we have ARKit and then ARCore. ARKit uses a separate module for face tracking. ARCore bundles it in, but again, it's dependent on what you're building for. If you're not building for ARKit, then you don't need to bring that into your project. And whichever platform you do, you still need ARFoundation to act as like the interface. Then from there, this project literally takes minutes to set up. So we'll bring in an AR session origin. So this is what's going to keep all of our tracking data in memory. It's also going to give us the camera. And this camera is basically going to manipulate our device camera. We can get rid of the original camera now. Then the only other object we need is an AR session. This is essentially a binder for the other object. Then from here, we can just bring in the additional components we want. So for this demo, I want a point cloud. So this is where we visualize the feature points. So I'm going to drag that down into a prefab. Then I also want planes as well. So I'll drag that down as well. And then I'll delete these from the hierarchy. Then all we do from there is we go to our AR session, and then we bring in these two prefabs that we just made. If anyone who doesn't know, a prefab is essentially a carbon copy of an original object we made that we can reuse later on. So we want a point cloud manager. So this is going to assign all these little particle effects to the feature points that we pick up on. So we drag that on top of there. Then we bring in the plane manager. And again, same thing with the planes. It essentially acts as a manager and then deploys them wherever we need to. And then we can go ahead and build that. That is a basic AR app done in about 2 minutes. I also want to show you a quick demo of something I built over at Riot not too long ago. So is anyone here familiar with League of Legends? Okay, one, that's a good start. So essentially what we do is we take all the information from the game and then we recreate it in Unity using their API services. But what we did was go a step further than that and then actually create it in AR. So I'm going to load in a session over here. And then, if it loads, maybe. Okay, we'll try a different demo. Let's try AR onboarding. So the main thing with AR is basically you need to have enough information to work with. So because this carpet's quite detailed, I have enough information to work with basically all these apps. So here we have a little bit of onboarding. So we tell the user who may not have necessarily used AR before to move the device around to establish these tracking points. So here I've changed mine to look a bit more, get rid of like that matte color in the middle. Then we can place down this marker and actually move the marker in world space. So again, even though this is technically an overlay, we're still moving it and scaling it based on the real world. Then we can place an object in. So here we have a little gear with a fake shadow on it. And even if we look away and then come back, especially if you've done markers before, the second you look away and come back, your tracking's lost. Whereas with world tracking, as soon as I look down and come back up, because we're still keeping all this information in our relative sense, then we know exactly where it is. So that's one of the big benefits of using things like world tracking. So let's connect back. Super quick. Okay, so a quick recap of what ARFoundation is. So ARFoundation is cross-platform AR development. It's available right now, so you can just go into preview packages, pull it down. We have built-in visualization, so you can get everything for free. All the code's there. You don't have to do anything yourself if you don't want to. More noise, so the more information around your world, the more you have to work with. And objects are always relative to the start of the session. Your mobile device isn't the main tracking point the whole time, which is one major issue that people run into. Quick tech recap. So we don't have any multi-threaded rendering support just yet. This isn't too relevant unless you're doing like really big models that really need to make use of those threads. It's 64-bit only, which if you have an AR core supported device, has to be 64-bit anyway. Minimum API version, and you also need a compatible device. So we can only do what those native SDK allows us to do. We can't do anything on our own, so we can't use a webcam, for example. We're still restricted to those native SDK limitations. And that's about it. We have a Discord server up now, so if anyone wants to learn how to do this, do you want support from our community, you can go to that link there. You can win some stuff just for coming to this talk. Isn't that cool? I can see everyone taking pictures now. We can win some shirts. Any questions about AR or general development?